Hello, welcome back to the video lecture series for Introduction to the Art of Programming Using Scala. In this video we continue our discussion of multithreading, and we're going to look at one of the commands for threads that we can use to help control how threads are working. And then we're going to look at race conditions. It's kind of going to fall out, which is a challenge that we run into, a problem that can occur in our programs when we involve multithreading. So we start with the code that we had last time. Last time we finished up where we created one additional thread and we had our main thread and we made them print kind of in an interleaved manner. And what I want to do this time is imagine the problem where I have a whole bunch of numbers and I need to add them all up. Okay. And so a first approach to this might be able to create some variable called count, and then at the end here I'm going to print out the count, and I want to create multiple threads that are going to add the numbers into this. Now in reality I would want these to either be pulled from a file or they would be generated by something. They would be something interesting, and I would split them across multiple threads. However, for our purposes here, it turns out I'm not going to go with interesting. I am just going to put inside of here a loop for j in 1 to, let's go to 100 million. And inside of this loop I'm going to add 1 to the count. So I'm adding 1 100 million times, and I'm doing that in 10 different threads. So basically I'm adding up a billion numbers. Now in this case all billion numbers happen to be 1, which is kind of boring, but it has the advantage that I know the answer. If I were to change this to something that was random, or if I were to have a file that had a billion numbers in it, it would be more accurate for what we're trying to do here, but I wouldn't necessarily know what the answer is that I was supposed to come out with, and I'd like to just have that automatically available to me. So I'm going to go with this. So we create our count as 0. We have a loop that's going to go through and create 10 threads. Each thread is, when it runs, going to count to 100 million and add in every single time 1 to our count variable. Then we start the thread and we're going to print out our total when we're done. And so if we run this, you can see what we get here. Well, this is 25 million, which isn't exactly what we were going for. What happens if we run it again? That's still not the answer that we wanted. And again, yeah, we're getting all of these numbers, and they're in the, anywhere from 10 to 30 million range, but they're nowhere near the billion that we want out of this. So what's going wrong? Well, turns out there are two things going wrong, and the first thing that's going wrong is I am printing count here potentially before this is done. I mean, now a sloppy way to do this, and this is not something you should ever do, would be to wait a while and then we'll print them again. Okay. Notice how the first time here that I print, I get a small number. After I wait for 1/10 of a second, though, I get a much larger number. And the question is, well, how long do you have to wait? And the answer is, you shouldn't have to figure that out. Okay. What I really want to do is I want to wait and pause until all of the threads are done. And that is exactly what the method called join does on a thread. So when you call join on a thread, what happens is the current thread pauses until that other thread is done. So I need to, instead of sleeping here, I need to join with all of the threads that I started up here. So in order to do that, I'm going to make a variable called threads, and I'm going to make it so my for loop yields values. And the values I'm going to have it yield are the threads that we've created. And I'll start the threads there. And we can see this winds up doing basically what we had before. And if we run it a number of times, you can see we have a number here, we have a number here. The second number is larger after we've done our pause. But I don't want to have just a pause. I want to use the join command to make absolutely certain that everything finishes. Okay, now, in describing join, I've kind of used a new terminology which is significant for threads, and that is to say that this is a blocking call. We've seen blocking calls before. When you called readline in a script, what happens? Well, your program freezes and blocks at that call until the user inputs something. Same thing happens with join. With join, the current thread, in this case the main thread, because I'm down here in the main thread, is going to stop and wait for whichever one of these 10 threads I am joining on to finish. If the thread's already finished, then it just keeps going. Short pause to check that it's done and keep going. But I do this for all 10 threads so that when it's done, I'm guaranteed that all of the 10 threads have finished whatever it was that they were doing. And you can actually see now that waiting 1/10 of a second probably wasn't long enough. The delay here is visible. And after that visible delay, we're now getting values that are in the hundreds of millions. Still an order of magnitude below what we expect to get. We should be getting up to 1 billion here. And that leads to the second problem. The real problem here isn't just that we aren't waiting long enough. The real problem is the fact that it turns out that this line right here, where I say count plus equals 1, it looks like a simple line and I'm just incrementing something, but in reality there are at least 3 steps to this. One is that I load in the value of count from memory. 2 is that I add 1 to that value, and 3 is that I store that value back out. And the problem is that if I have many threads that are doing this all at once, they can conflict with one another. So I can have one thread, so for example, if one thread loads, increments, and stores before another thread loads, increments, and stores, everything's happy. The problem comes when one thread loads, and then before it manages to get to storing, another thread loads in as well. Well, now I have 2 things that have loaded one of the old values. They're both going to increment it, and they're both going to store back, and only one of those stores is going to kind of win. In some ways, it's like an anti-race. Whoever's slowest wins, because they write it out. They write their value out to the memory after the other one. And so I actually have 10 threads here that are competing, and they are all overlapping. So they're all reading this value and writing out to it, and it's all jumbled up. And so a lot of those increments wind up being lost. And in fact, you can see here, because I'm going just a little bit over 100,000, I'm losing almost 90% of my additions, which it turns out that is what we kind of expect here, because I have 10 threads that are all vying for control. So anytime that you have a mutable memory like a var, and you have multiple threads where at least one of them is writing to that memory, you have the potential for a race condition. If they're all reading, everything's fine. You can have as many threads reading from it as you want, because if you're reading, then the mutable part isn't significant. But as soon as one thread starts writing, one or more threads start writing, then you have the possibility that the behavior of your program is going to change, and it's going to depend upon what thread gets to a particular location first. So we'll come back in the next video and we'll look at some ways that we can help to deal with this and to fix this problem.